So he was saying something to the effect that most photo browsers look like that. I'll keep on going from here. They didn't present any of their work yet, so no tree maps involved yet.
Searching collections of photos. We developed PhotoMesa, a new application that focuses on browsing of images. One of our goals with it is that there is no overhead in getting started to use it. You simply open up a set of directories. PhotoMesa finds the images in all the directories you open and presents them in a single overview. It uses a modified tree map algorithm called quantum tree maps to partition the space on the screen, breaking it up into rectangles, one for each directory of images. I can get a preview of any image. Then to see one directory in more detail, I can click to zoom in. PhotoMesa uses a zoomable user interface, or ZUI, and has very simple controls for zooming in and out, so it is easy to zoom in for detail and zoom out for an overview. As I move the mouse, a red rectangle shows where I will zoom into when I click again. When I get close enough, the full resolution photo is loaded. Pressing the right mouse button zooms out. The arrow keys are used to pan around. One of our goals has been to mix the intuitive nature of ZUIs with the power of traditional interfaces. The search pane shows a list of directories and can be accessed directly with the mouse. The search pane also allows you to search for images based on the file names. We can use this for a simple way to find all of the images of someone, for instance, me. PhotoMesa will regroup the results with the same layout algorithm, so we not only get the results of the search, but also see how the pictures are organized. While PhotoMesa groups images by directory by default, it can also group images by other metadata. Without requiring the user to annotate the data, our sources of metadata are limited, so we used what the operating system offers us, file change dates and file names. PhotoMesa can regroup the images based on the dates of the images or based on the words and file names. By selecting View by File Name Words, we can see what images are related to each other across directories. PhotoMesa forms a new group for each word in a file name. So, if there is an image with the name Ben Hiking, that image will go into two groups, one for Ben, one for hiking. Then we can look at the Ben group and find all of the images of Ben. Finally, we have begun to explore alternative layout strategies. While the quantum tree map approach works well, it wastes some screen space. So we have developed a new layout algorithm called bubble maps. This wastes less space, but creates more complex shapes. PhotoMesa is written entirely in Java and is built using the Jazz toolkit for zoomable user interfaces, also available from HCIL. We are happy to make PhotoMesa available for you to download from the web and hope that you enjoy it and give us feedback on how it works for you. A red rectangle shows where I will zoom into when I click again. The photo is loaded.
Okay, so this guy here to the left, he's Ben Schneiderman. He's the one who came up with the idea of tree maps to start with many, many years ago. And then he promoted it, and he has other things. Just because he was in the picture, might as well mention him. So the next one, we're jumping from Maryland, HCIL, going to Georgia Tech. These, the Georgia Tech are the ones with dust and magnet. Okay, so starting in 3, 2, 1.
This video illustrates the Fund Explorer system that introduces the concept of a context tree map. Fund Explorer helps investors manage their portfolio by seeing fund overlaps and exploring how to diversify their portfolio better. The Fund Explorer interface shows the stock market view on the right. Each small rectangle is a particular stock, and the stocks are grouped into larger rectangles that correspond to market sectors. The left fund list area has regions for all mutual funds, filtering operations, and the actual investment portfolio. Let's suppose that we have $1,000 invested in the Fidelity Spartan Fund. We select that fund from the list, put $1,000 into its holding, and give it a light green color. Finally, we add it to our held list. Note how the rectangles corresponding to stocks held by this fund have grown. Their areas now correspond to the relative holding weight of each stock by the fund. In a normal tree map, stocks not held by the fund have a zero value, so their rectangles would have zero size and not appear in the display. In the context tree map, however, zero valued items are given some constant proportion of the display area, and thus each appears as a small rectangle. Here, these items represent stocks not currently held, but ones that could be purchased to diversify our portfolio. Notice here that the Fidelity Spartan Fund does not hold any stocks in the industrial sector. We would like to broaden our portfolio and include funds that hold stocks there. Fund Explorer provides an easy way to explore this possibility. By clicking on the border of the industrial sector, it becomes highlighted in red and is used as a filter. Thus, only funds that hold stocks in this sector are shown in the center list on the left. By clicking on a fund there, such as Pegasus International, all the stocks held by that fund are highlighted in a blue outline. Pegasus only has one industrial stock, and it has a lot of overlap with the Fidelity Fund we already hold, so let's look for another option. Let's try out Harbor International, and we notice it has much less overlap, so let's buy $1,000 of that fund as well. Give that fund a yellow color, and add it to our held list. Now note how the portfolio view on the right shows our stocks from both funds. When we click on an individual stock, such as Nintendo, the filter list updates to only show funds that hold that stock. Clicking on a second stock, such as Autogrill, further refines the list to only show funds holding both stocks. Acorn International is the only fund to do so here. Let's see how well that fund would mesh with our portfolio. To do this, we simply click on the fund to the left, and all the stocks it holds are shown on the right. This fund appears to be a good fit for us, as it only has a few overlaps with our existing portfolio. Stocks held in multiple funds are indicated here by rectangles that have multiple colors. The size of each region is determined by the relative holding from each fund. We also like Acorn International as a choice because it adds a few more stocks in the technology sector that we wanted to beef up. Notice how the use of repeated item selections and filtering operations provides a kind of dynamic querying capability to the Fund Explorer interface, therefore promoting exploration of possible stock and fund purchasing strategies. Together with the context tree map visualization technique, these operations make Fund Explorer a potentially valuable tool to investors. Furthermore, these ideas could be adapted to other domains in which exploration and the potential addition of zero-valued items frequently occur.
So the main advantage here, zero value, and then they use the tree map to filter. They used it for interaction. They kind of otherwise they could have written a separate interaction tool, but it worked pretty well this way.